Okay, last time we already done for this thing, okay? That means the Boolean algebra. Only thing, I want you to memorize the formula here. If you get A, B, not A, B, and not A or B. So the first one, what we get? Not A, B equal what?
A naught
Not,
plus B naught
not A,
or plus B naught.
or, perfect, not B. How about the second one?
A naught and B naught. A naught dot B naught.
Perfect. That means this is the product converting into the sum, and this will be the sum converting into the product. Okay, that's only thing I want to memorize that. Okay, now last time we already talking about the AND gate. So if I get A equal 0, what output?
0.
They must be 0. Okay, telling me what the input be supposed to be.
If both the inputs are 1, output is going to be 1.
Okay,
Anything.
A equal 0, then output must be 0. What happened to the input B? What logic you think?
Anything.
Anything.
That's what I want. That's why I say don't care. Now, what that mean? Don't care. Don't care. That means they can be either 0 or 1. That doesn't matter. The reason I bring it up, the thing is that related into the troubleshooting. When you apply a 0, output must be 0. Now, if they not 0, that means something wrong. What can we do? Where do we check?
The connections.
No, not talking about connection. We're talking about using the meter to measure the voltage, the logic you want. When you apply a 0, output must be 0. But they not 0. What do you think you can do?
Check A.
Change the component.
Now, what we supposed to do?
Replace the AND gate.
No, what I'm saying is when you apply a 0, output must be 0. But they not 0. How can you fix the problem?
First, you use a meter to check the voltage at A.
Perfect. That's what the people know how to do. You check the meter to check it here for 0, right?
Yes.
0. You connect your meter into A, make sure you get a 0. Now, when you measure the somewhere, then you can get what you want and you cannot get what you want. Okay? Now, if you measure at the pin A, you get 0. What can you do?
Replace the IC?
Exactly. Only thing you say, okay, this one is not working. Why? The thing is input A 0, output must be 0. If they not 0, then that. Okay? However, what happened for the input B?
It doesn't matter. It could be 1 or 0.
That's what I want. When I say don't care, only thing telling you, when you troubleshoot it, never measure any input, you say don't care. The thing I don't care, either 0 or 1, that doesn't matter. How can we have to measure? Okay, that is the key point for troubleshooting. The thing is you have to do it when you start doing your lab. When something going wrong, you must be know how to do what to do. That's the main thing for this course. Deal with a problem.
And in this case, do we use the voltage setting?
What do you mean?
On the multimeter, you're using voltage to measure A?
Yeah, just the voltage VDC. Only thing meter will be using VDC. The thing is, you understand logic. Less than 0.8 volt mean logic 0. Higher than 2 volt will be logic 1. But
Right.
that will be volt DC, nothing else. And the next one will be the OR gate. Okay? For this OR gate here, if I say I get a 0 here, what output?
It depends on B.
Exactly. That is output is not, you cannot tell output equal until you know B. Okay? So if I get a B here, then the output will be 1, right? That's working correct, right?
Yes.
Okay, now if it's not 1, where you want to check?
Check B.
Check
B.
perfect. That's perfect. The B you want it to be a 1. OR gate, you get an input, 1 input equal to 1 output must be equal to 1. So basically, A make nothing, okay? You don't care about A. A0 cannot make the output to be a 1, okay? An inverter, that's easy, right? Inverter means input 1, output 0, where you see the bubble, okay? Input 0, you get output 1. Now, this is the key point right here. NAND gate. Only the equation you will be using will be this equation right here. The thing is not A and B that cannot telling you to recognize what output supposed to be. However, if you get a not A and not B, easy. Now I can telling you, if you get a 1 input A equal 1, what output? A equal 1.
Depends on what B is.
B is.
Depend on what B. I easy to recognize by this formula here. Okay, the thing A1 not A will be 0. And you all with not B. If you don't know B, you cannot know what is the output. Okay, however, if I said I get A equal 0, what output?
One.
Must be 1. Why do I know that? You can see
There is an inverter on the back side. So 0 is going to be converted into 1.
Right, exactly. A0 not A equal 1. 1 or with anything, no matter what, they must be 1. So one input equal 0, then output must be equal to 1. Okay?
Okay.
So that is the equation you must be memorized. Okay? Easy to telling you right away if you already know the input. And also in here, they given you the IC here. When we start doing the lab, make sure you know which one is the pin 1. Okay? Which one is pin 2, 3, 4, 5. Okay? And normally for 14 pins IC, they must get the power and the ground. And the power will be 14 and the ground must be 7. So you must connect that before you can make any more connection. IC without the power, they not working. Okay. This the same thing. Okay. And also exclusive OR. You need memorize one, then you can recognize the other. Exclusive OR, if you get a 1 here, 0 here, what out?
1.
1. That only telling you from the two table. When the input A, B different, output 1.
Right.
When the input A, B the same, output will be 0. Okay? That means if this one here, you get 1. 1 and 1 mean the same, output will be 0. That's easy to recognize. Okay? And the next one will be this guy here. Exclusive NOR, same thing, they just reverse what exclusive OR. Okay? For example, in this case, exclusive OR will be 0. And now if you're doing the same thing, 1 and 1 here, then that will be just opposite. Okay? If you get any confusion, okay, and let me know. I want every time you see the gate, you get an input, you're able to tell me what right away what output. Okay? Now, this is just try to give you the picture, okay, not go much to the detail. The thing is, what the Boolean algebra supposed to do. When you get try to design a circuitry, then you have to get the input, okay, and you get to get the output. That coming up with the equation. Now I just given you the equation here will be implement expression. Implement, that means they want you to draw this circuit, okay? A or not A, okay? A or not A, if you want to draw. Now, I'm talking about how can we draw that? That means you get the equation and you want to draw the logic circuit or the circuitry. How? A or A not B. How do we draw it? Do you know how to draw the circuit from the equation? X equal A or with the not AB. Okay, look like nobody knows, right? Okay, the way to draw draw the inverter or the AND gate before you able to draw the OR gate. Okay. The thing is we not design anything. So that's why I not emphasize on that thing. But if you go to college, then you hit into that. Draw inverter first. Now you get A if you want not A. Then you can see that will be A, not A. Right? Not A. That is the you need to draw first. The second, you will be draw for the AND. Okay? So not A AND with B. Now they can be AND here. AND with B. So that will be not A. And with B. Okay? Then the last one, you will be draw for the OR. So now OR will be AND, or A will be OR with not AB. This is a not AB and this will be A. Okay? And now you get OR gate. That is how to draw the expression or the equation. Draw not, then and last one will be OR. Okay, any question? Any question?
No.
Okay, if it's not, now the Boolean, try to simplify that equation. Try to make it less number of gates. Okay, so if you're looking into here, okay, then they can tell you A or not A, B. Okay, so they can adding A plus A, B, then or not A, B. Okay, and they keep going. Okay, finally, they get the equation X equal A or B. This is the final circuit. Okay, that's telling you what? Telling you the circuitry at the beginning you draw, you get 1, 2, 3 gates. And after you try to minimize number of gates, you get only 1 gate. And the circuitry will be working exactly the same. Can say 2 gates. And each gate, maybe each IC, you can cost you about 25 cents. Okay, so they can save more money when they can build 100,000 more, cost a lot. So that's why engineer, when they design the circuitry, they have to guarantee the minimum number of gates. Okay, in order we can build. But this is a long, long time ago, not applied at this time. Okay, this time they will be using another way to do the same, but more easy to do. This is a very, very tough to minimize. Okay. This is another example here. Okay. If whoever want it, you can read it. Okay. Using the Boolean. We don't want to waste the time to spend on that. Now, how to get truth table using two power of n in a number of bits. Okay, the truth table, the relation between input and the output. I given you a problem, simple here. You want to design a alarm circuit for your car. Then you have to telling me how many input you want. For example, you can say, okay, if I turn on, if the door open, they turn it on. Okay, or in the trunk open, alarm will be on. I pick only two input. That's what I call A and B. For two input, the truth table, you're using the formula 2 to the power of 2. Automatically, you get 4 combination. Okay, no matter what, this is input, 4 combination, you get 2, 0, 2, 1, 0, 1, 0, 1. Okay, for each input here, A, B, you decide the alarm to be on or off. Okay, when they open, that means you have to tell them, B0 and B equal to 1. B0 means the door closed, or B equal 1 means the door open. Same thing, A0 means nothing. A equal 1, that means the trunk open. So from this design, you can tell what output equal. Okay, that means 0 means open. 1 means close. So open means and close means alarm off. And that will be alarm will be off. So if A0, B0, what do you think output?
0.
0. Not on. 0, 1.
0.
0, 1. That means you get a 1. 1 will be closed, right? So
Right.
you want it on,
1.
right?
Yes.
Okay. So that is given the simple truth table. And now if you get 3 inputs, okay, 2 to the power of 3, you get 8 combination. First will be 4, 0, 4, 1, 2, 0, 2, 1, 2, 0, 2, 1, 0, 1, 0, 1, 0, 1. This cannot be changed no matter what, depending on how many inputs you get. And they will be output depend on your design. They can be 1 or they can be 0. Okay. And the last one, now you already know that up to the point we will be learning 4 inputs, automatically you get 8, 0, then 8, 1. And the second will be 4, 0, 4, 1, 4, 0, 4, 1, 2, 0, 2, 1, and 0, 1, 0, 1. That is how to make the truth table depend on input condition. And the truth table, you cannot make a difference. You must be follow these rules. Okay? And now, K-map. This is another way to minimize the logic gate in the circuitry. Before they're using a Boolean no longer. Okay? And the K-map will be the new one. K-map, CognoMap, provide a systematic method for simplified Boolean expression. And if properly used, will produce a simplest sum of product or product of sum. expression possible. Okay, for two variable K-map, same thing the two table. If you get two of two, you get 4 cell. You see X1 here will be a cell. Okay, see that? This cell here automatically for two variable A and B. Then you get 4 cells. Now, A, that means here, A can be 0 or A can be 1. B here, B can be 0, B can be a 1. Now, if I want to identify A and B inside each cell, so when I'm looking here, this the first cell, I'm looking up, A0, so I say not A. I'm looking into the left. B equals 0 will be not A and not B. So this point will be what? Looking up A1, that means A. Looking into the left, B0, not B. A, not B. That's what we call a product. And this one will be go up, not A. Going left, B. Not A, B. Okay, and so on. And now if you get a 3 variable, A, B, C, then the truth table A, B, C also must be get 8 cell. Okay, like the truth table, same thing. 2 power of 3 will be 8. And A here stands for 0 and 1. And B, C here on the left column, that's for B. Right column, left for C. So what I want here on this cell, okay, what product? Looking up, 0 means not A. Looking into the left, B will be not B, C will be not C. Okay, so on this cell right here, you look up, A equals 1, that's A. You're looking into the left, B1, C1, so that's why A, B, C. That will be identified on of the product inside the K-map. Any question? Easy for you. Must be clear, so later on you're able to do. They've just given you 4 cell, 4 variable. That means you get 16 2 to the power 4, 16 cell. And on the right, they identify what cell for each product. You can look into that if you already know the other two. Okay, now they're talking about CognoMap method. CognoMap is a graphical device used to simplify a logic equation or to do converting a truth table to its corresponding logic circuit in a simple, orderly process. Each product in the expression should be mapped by 1 to the corresponding cell in the K-map. The cells that do not have a 1 are the cells for which expression is 0. Adjacent cell is differ only in 1 variable. Once K-map has been filled with 0 and 1, the sum of product expression for the output can be obtained by ORing together those squares that contain a 1. That is general about the CognoMap method. Okay. Next will be a looping. The expression for the output can be simplified by properly combining those squares in a K-map which contain 1. The process for combining this one is called a looping. Looping only. You can get loop of 1 to 1, 2 to 1, 4, 1, 8, 1, 16, 1. Okay, that is the rules. You cannot grouping 3, 1 or 5, 1, 7, 1. No. They must be 1, 2, or 4, or 8, 16, or 32. Loop any pair necessary to include any one that has not been looped, making sure to using minimum number of loop. Okay? That means if you can make a big loop, you must make a big loop. You cannot break it into 2 loops. So if you can loop maximum number of 1, you must do it. Form the or sum of all term generated by each loop. Okay, so you get a product for each loop, then you can adding up. Procedure. Construct a K-map and place 1 in dot square corresponding to the 1 in the truth table. Place 0 in the other square. Examine the map for adjacent 1 and loop dot 1 which are not adjacent to any other 1. This is called isolate 1. Next, loop for dot 1 which are adjacent to only one other 1. Loop any pair contain set of 1. Okay, so basically that will be telling you how to loop. Okay, you can read. When we do exercise, I will be happy you easy to understand. Now, the fourth one here. This is the fourth one here, 3 variable. So up here, C stands for that one. Not C here. Not A, B. Okay, will be here, right? Not A, B. Not A, not A, not B, not A, B. Okay. So this is they already mapped. That means they already put a 1 into the K-map. Only thing they're asking you to loop it. So the thing is, when you looping, okay, loop the first isolate first. That means they don't have any friend, any neighbor. Loop first. Then now you can say, just 1 minute, okay? Hello? Có anh nhưng mà giờ tôi đang dạy học. Ok. Ok, rồi. Okay, so now we need to talking about adjacent 1. That means this one here and this one here will be a neighbor. They get a different only one line here. Okay? And this one and this one a neighbor. This one and this one will be a neighbor. Okay? However, this one and this one not a neighbor. Okay? However, this one and this one will be a neighbor. So they say, when you make a big loop, you must do it. That means I can loop from here to here on 1. I cannot say I make this to 1, then make this to 1. No, that's wrong. So after I looping, and now I have to write the equation. X equal, you see the looping here, going from the top to the bottom here. That means you don't care on the left side here. They already cancel. you reading only the first one. Okay, so H will be equal to C. Okay, and the second one here, the same thing. You see one here, one here, one here, one here, that's all a neighbor. So you get only one loop. When you look from the left to the right, on the left to the right, you don't care on anything up here. Care only whatever here. So that's why equal A and B. Okay. And now on this one, you get one here, one here, one here, one here. They will be adjacent. Why? They will be neighbor. Like the paper, if you wrap around, so that will be friend with that guy. That will be neighbor. And if you wrap another way, then that one will be neighbor. That one will be neighbor. So that's why the equation, they can get not B. How come they get not B? Remember, when
Because
you get not C and C, cancel. Okay, you don't care about C. If you're looking on this guy here and this guy here, on the left, you get not C, not D. On the right, you get C, not D. So C not and C, they cancel out. You can get only not D. So that's why you get not D right here. Okay? And now, if you're going this guy here and this guy here, okay? On the first one, you get not A. And the second one, you get A. That's okay. However, on the first one, you get not B. And the second one, you get not B. Okay? They already cancel it. So that, let's see. Not A and A, they cancel out. And not B and not B, they will be not B right here. That's how to write the equation. The last one in here, I'm talking about this loop first. Now, on this loop, you're looking on the top. Looking on the left, on this way, they do an A, B first. So looking on the left, what you think you get?
A.
Yeah, A because B and not B cancel out.
Perfect. A, okay. That means you can get right here, A. Now you're looking on the top, what you get?
C and D.
Yeah, right here, C and D. So then for that guy, okay? And now, that one. Basically, only one, not any neighbor, you must be doing first. So, looking into the left, what you get?
Not A, not B.
That's why
C,
you get right
not
here.
D.
Not A, not B. And you're looking up, you get C, not D. That's how to write the equation. Okay, the last one. Take that up here. Now, the last one will be for here. To the left, what you get?
B.
A and not A cancel out, so it's B.
Right, you get B right here. Go to the, on the top,
D.
you get D, perfect. Okay, you can see that the equation let, variable, you get a let gate. This one get more gate. However, this is a minimum. So you can say the K-map very logical way to do the job. That's what engineers using to do it, the job at this time. They're not using Boolean. Okay. Now you do for me. Okay. I want you to do it for me. Oh, in here they already get the answer. Okay. So for your guy, you look into that. Now, that's what you need to do for me. Okay. You K-map to minimize following standard sum of product expression. Make sure you try get along with sum of product or product of sum. Sum of product, that means you get this is a product here. This is a product here, product here, product here. And they adding up. That's why sum of product. Okay, map for me to see who can get the mapping right and the looping right to get the equation. I given you the example. First thing you're looking for equation A not B C. A mean here, right? No, sorry, they go opposite to me. Okay, A mean on the left.
A, not B, C will be in the bottom right corner.
Okay. This is for A, everything for A, right? This is everything for C. Okay. That will be A here, C here, and every on the this way will be for C. Now,
Second column is B.
Yeah, second column is B.
just a minute. Now, I give you example. A, not B. A, not B right here, right?
Yes, sir.
Okay, A, not B, and C. That means you get a 1 here, 1 here, correct? The thing is C will be here. Top to the bottom. Okay, now go to not A, B, C.
Mr. Fan, why do you have a 1 on the 0 column?
1 on what? Which one?
On the 0 column?
0 column. What do you mean 0 column?
The first column.
So first column, the first
Yeah.
yeah, going down, and then you have a 1 for A, not B, but then a C. So therefore, it should be 1 at the
That's okay. You say 0, right?
right. Okay.
Shouldn't that, yeah, that column should be A, not B, not C.
Okay, perfect.
That spot.
Yeah, you do better than mine. Okay, that is done the first one. Tell me the second one.
A,
Not A.
B, C. So it's 1.
Not A, B, C. Is it that one?
Which spot are we? Oh,
Yes.
I see. I
Right?
didn't know which one we were doing. Yes.
Okay, second one done.
C.
Not A, not B, C.
Top right corner.
Right. Right? That one done. Not A, not B, not C.
Top left corner.
Perfect. A, B naught, C naught.
Bottom left corner.
A here. B, A here. Okay, A. Okay, B naught
Bottom left corner.
here, right?
Yes, sir.
A, B naught, C naught here. Okay, the rest will be
0, 0, 0.
0. So tell me what equation equal. That means now you have to loop it. Who can get the equation for me?
I believe it's exclusive. Oh, no. Sorry.
So what you get? You try yourself, okay? Make sure you follow it. Okay, this really neat. That's why we go into the detail here. First thing we're talking about looping. You
So
can,
loop the first row.
okay, first row.
A, B.
You said this one, right?
Yes.
Is it right or wrong?
Wrong. You loop it around the bottom.
Exactly. Now you can see. When you did it like the paper, when you wrap it, so the first two, okay, and the bottom two will be adjacent, neighbor. Okay, so when you looping, you must loop 4. 1, 2, 3, 4. You can looping this way.
Oh, yeah.
Okay, what you get?
Not B?
Perfect. You understand now.
Thank you.
It's B naught, right?
B not B. Same thing.
Doesn't matter.
Well, it gets confusing when you have more than one letter. So
Yeah,
That's-
that's true. That's true. The order that you say it in.
So you
Yeah.
cannot be or be not.
Same.
Now, when you looping from the left to the right, you don't care about C. Okay? You don't have to do anything with C. And then on the top, you get AB0. On the bottom, you get 1, 0. So that's why A equals 0 and A equal to 1, they cancel out. You can get only B equals 0, 0. That's why you get not B. Then you have to OR with the next loop on the left over here. Okay? Then how do we loop that?
Not A and C.
Now, this one in here still neighbor with that guy. Even they already looping, you still can be using that. Okay?
Right. Isn't that? Yeah. So wouldn't that second loop be not A and C?
Not A and not A C, right?
Yes. But you can't do 3, so you don't roll it over to the bottom.
No.
You do 1, 2, 4, or 8.
Yeah, 1,
16.
2, 4, 8, 16, 32.
Got it.
Any question? How to mapping the product into the K-map? That's the first. Second thing, how to looping. Last one, how to write the equation after you looping. That's what you need to know. Okay, some student asking about the textbook. I said, don't need the textbook. Please read my handout over. Okay, the thing is on my handout, I combine two different book in try to get the way easy for students to understand. Make sure read over and over. Anything you confusing, bring it up. We'll have to solve the problem. If there's no question here, I want to asking you one more thing on that one. Now, I changed it. Anyway, we just done, we got a one here, right? 0, 1, 1, 0. Now, I change that to 8. What 8 means?
Okay.
Don't care.
Don't
Anything.
care. Don't care mean they can be 1 or they can be 0. So when in the K-map, you see a don't care. If this don't care helping you to looping better, you said they be 1. If not, then you don't need to know. You don't have to do anything. In this case, I really want don't care to be a 1. Why? The thing is I can loop for here. Instead, we loop before you get on the 2. Okay? That is the purpose of don't care. When we get 8 mean don't care. If they really have to make a bigger loop, then you treat it to be a 1. Otherwise, they be 0. Okay, now loop that for me. Loop and give me the equation. Okay. I can say X equal. Easy to loop, I can loop this one first.
Does it matter which one you loop first, Mr. Pham?
Doesn't matter.
Okay.
Only thing you must be looping on 1 in the map. Order before or after doesn't matter. So this will be equal what?
AB. Yeah,
See,
Perfect.
AB.
Or with like loop. You can loop this guy. No, that's wrong.
You do the 2.
Yeah. They will be loop this one here. right?
BC.
That will be B and C. Yeah, you be very good. And the last one here.
Not A, not B, not C.
Okay, not A, not B, not C.
Or A not, B not, C not.
Thanks, Adam.
A not, B not, C not. How about Mr. Smith? I didn't hear you.
He's eerily quiet tonight.
He's sleeping.
Quiet today.
He's sleeping.
Is he in Tech 1 tonight?
Now he in here. He prefer digital than electronic.
He's just laying low.
Okay, now try to get that one. X equal. You know, a lot of exciting. If you understand, you can see how they design the light on the street when they turn off, when turn red or green or yellow. Okay, loop it. If I do it, I do that one first. Right?
Yes.
Okay, what you get? Not
B.
me.
Not B, yes, sorry, not B.
Oh, you can do that guy.
Not A, not C.
Okay.
Not A, not C. And the last one.
AC.
AC, that's yes.
Let's see. Okay, any question?
Yeah, so can you explain on the second map, can you just explain how you get these, how you get the final equation? So just go through it if you could, please.
Okay, how do I get the final equation?
Yes, for example, like that first term, not B, can you just, because I think this is the problem for a few of the people in the class, including myself. Can you just tell us how you get the not B?
Can I give it a shot?
Sure, or sorry. Yeah, whatever.
If you take the two top squares and combine them with the two bottom squares, the not B or B at 0 value is the only common among them. If you look at all those squares, you can have an example where A is 0, but then on the bottom, A is 1. And if you look at either column, C is 0, but C is also 1. So both of those examples cancel each other out. The only thing that's common to those 4 squares is that B is 0 for all 4 squares. So it's not B.
Okay, make sure you understand. The first two on the top and the second two on the bottom. It's like the paper. If you wrap it around, they will be a neighbor. So what I'm saying, inside the loop, if they get a value 0 and 1, automatically they cancel out. So if you get on the top, okay, C equals 0, C equals to 1, so no longer using C, okay? And on the top and the bottom here, you see you get A 0, A equals 1, they cancel. You can get only B0, B0. That's why you get not B.
You're just going by process of elimination and finding what all of the squares in the loop have in common.
Thank you.
But it has to be true for every single square in the loop.
The thing is, if you be the engineer, you must be design the circuitry, you must using this. You minimum the number of gate. Okay? And now they're talking about the truth table. You get the truth table input ABC, output I. Automatically you understand you get a cell for the K-map. So in order to loop, you put a 1 into the K-map, you don't care about this equation, but you care about the truth table. Whenever you get a 1, you can put into that cell. At the cell, not A, not B, not C, not A, not B, not C, put a 1 here. And this one, only put a 1, okay? And this one will be A, not B, not C, okay? A here, not B, not C, second one, okay? And the next one here, then you put it up here. And the last one, that one here, okay? So when you get the truth table complete, you don't have to care about this equation. Only care about mapping 1 into each product here. Okay, each product here. Okay, that's for converting from truth table into the K-map. Okay, so basically this they just given you another one for 16 variable. That means 4 variables you get 16 cells. Only thing they given you I care, that means don't care. Okay, and when you mapping don't care in here, depend. If you want that don't care helping you to make a big loop, then you better put a 1. You get a 1 in here and 1 in here, okay? Instead, you can using that one, but they're not allowed. The thing is you get too many don't care here. And this don't care will be helping you if you put don't care equal 1 here, 1 here, 1 here, 1 here. So you can get a big loop. Instead, you get A, not B, not C. Now you get only A. That's why we try to explain to you about don't care. Okay? And if you get a 1 in here, they say, I get a 1 in here, I can loop in here. Not A, B, C, D. But that's not good. The thing I get a don't care here, and the don't care here treat like a 1, so I can loop you. Okay? So I still get only B, C, D. Okay, anything on this thing? Okay, now, complete design a problem. 3 logic signal line CBA are being used to represent 3 bit binary number, which C as a most significant bit, and A will be a lead. The binary input are fed to a logic circuit that produce high output only when the majority input binary number are 1. So this is a process you must be doing. First thing, number one, complete the truth table. For input, output, include the product term. Using K-map to minimize the output sum of product. Draw the logic circuit. Now you run PSpice to simulate the circuit. Write the test program to test the circuit. Build the circuit. Test the circuit using your test program. Okay. Now, complete that one. First thing you know, understand you get three variables, ABC. Automatically, you get the truth table. And now your job will be find out what the output x equal 1 or equal 0. So, can you complete that for me quickly? The first one, you get 0, 0, 0. What? Output.
0.
You understand the problem they say is the binary input fed into the logic circuit that produce high output only when the majority of input binary number are 1. So the first one, 1 or 0?
0,
0.
0.
0. Second,
0,
0.
night,
0,
0.
night,
1,
On the last one will be 1 because the maximum
0,
on the bottom, the last
Zero.
one.
0.
1, and 1.
the thing is majority. You can get that one only 1, 1. They cannot be majority, right? Majority, that means you have to get 2. 2, 1. Okay, after you complete the truth table, they want you to put a product term. That means in that one, they will be not C, not B, not A. Okay? And then,
No, I did. Mr. Fem, I didn't follow. Why not C, not B, and not A? How?
yeah. C0 be not C, B0 not B, A0 not A.
The answer is going to be 1 in the product term.
That they must be in the product. Not C and
No,
not
but,
B and not A.
no, but why you are writing not C, not B, and not A?
Right.
But I didn't follow why you are writing not C, not B, and not A. What do you want the answer? Product term 1?
Now
Because
C,
they're all zeros.
C must be MSB, most significant bit. Okay.
But
When you get the CBA, C we call a MSB. A will be a LSB. Most significant bit, least significant bit. Okay? They must be this way.
If you have a 1 at any of those, that would, if you have a 1 at C, that would be C, but since it's a 0 at C, it's not C. And since the same is true for B and A, it's not C, not B, not A.
so my question is, in the product term, the first one, what he wrote, C dash, B dash, and A dash, we want to bring 1. That's why we are taking C dash. Am I right?
No, we don't want it to be 1. We're just writing what the product is.
So why can't I write ABC? I can write ABC also.
No.
You have to following which one is the most. We can do the least. Okay, now. We don't care on that one. I writing only 1. When they get a 1, I want the product. What in here?
Not C,
Not C, not
B,
B, and
A.
not A.
not
Not C,
Not
B, A.
C, B, A.
perfect. That one.
C, not B, A.
A, yeah.
That one.
C, B, not A.
Not A.
Last one.
There it is.
ABC.
CBA.
Mhm.
Okay. Okay, when you get a problem, you have to understand what problem they want the output to be 1 or 0 in order complete for your design. Now, they want complete for the K-map. So you can get not C, BA, not C. Okay,
Bottom left corner. Oh, I'm sorry, bottom right corner.
right here, right?
No, but yeah, bottom right corner. Yes, sir.
So you get one right here.
Yes.
That's the first one. The second one will be C, not BA. C, not B, A. Right?
Yes, sir.
Okay, the next one. C, B, not A. C, B, not A. Right?
Perfect.
And the last one, C, B, A. C, B, A here, right?
Excellent.
Okay, the red will be 0. And now output H equal. We can loop this guy. Will be
BC.
perfect.
BC.
BC or
C, A, AC.
AC or
AB.
AB. Okay? That means now you get this equation here. And basically you have to draw the logic circuit. That means you get B and C, A and C, A and B. Product first. Then after that you can draw the OR. Okay? I given you example. That one B, C, that one B, and C. Now you get a second OR. Okay? A and C. C here. A here. A and C. And A and B. Another N. A here. And B here. Okay? Then now you draw that guy. BC or AC.
OR gate.
BC or AC. Then now you draw that one. A, BC or AC or AB.
It's connected to the output.
See that? That's how to draw the logic circuit.
I like this exercise.
I think that's very interesting if you really understand what the engineering they doing. Okay? Next step, and you will be go into the PSpice to
Yay.
draw this circuitry and simulate it. Okay? simulation program will be helping you when you given the input of your circuitry. Simulation will be helping you to telling you what output equal for each combination of the circuit. Now, how to use PSpice to simulate the digital circuitry? If you're looking into this table here, input here, okay, we don't get output. Simulation telling you output. However, computer cannot understand 0 and 1. When you enter 0 and 1, they cannot understand. Okay? They understand the waveform. So in order to get this waveform here, you can see A first. A 0, then 1. 0, 1, 0, 1, 0, 1. So that's why you start 0, 1, 0, 1, 0, 1, 0, 1. And each time for logic will be 1 microsecond, for example. Okay? And now you can draw for B. B will be 0, 0. That means 2 microseconds. Then 2 microseconds for 1. Now you're looking here. 1 microsecond. 1 microsecond. That means 2. 2, 0, then 2, 1. 2, 0, then 2, 1. Okay? And the last one, you get 4 microseconds for 0 and 4 microseconds for 1. So that's why 1, 2, 3, 4 microseconds for 0 and 1, 2, 3, 4 microseconds for 1. Okay? And they telling you this waveform are using to add include file in the PSpice. Okay? In order to attribute for include, double click on include, select file name, enter whatever here. To edit, double click on this one and you say yes, typing your data. Okay? This is the way how to type in data. On this one is first line here. Only one thing need to be changed will be US1 or US2. That means for each input, you get 3 inputs, so that's why you get 1 US2, US3. The rest here cannot be changed. Okay? And the first one is the name. If you're using in your circuitry input A, then you have to identical A. If you go into the circuitry, you can see you're using A, then they must be A. B, they must be B. Okay? So now I put an A. And the second line here, no change. Next line, the first one 0 at means 0 second. At the first beginning, what logic? You're looking in our timing right here. At the beginning, the 0. So that's why you say 0. And the question is, they will be 0 for how long? How long the 0?
1 microsecond.
1 microsecond, then they go to 1.
1.
Okay, so that's why I say plot 1 U. That means they stay in 0 for 1 microsecond, then they go to 1. Okay, and after that, they keep repeat the same thing. Nothing change. That's why they get a formula. They call a repeat forever. What they repeat? They repeat 1 U second for 0, 1 U second for 1, and they must be and repeat. If you're using this formula, only your change will be here. Repeat forever and repeat cannot be changed. And the same thing on the second one. Okay, a second one here, they start at the 0. How long they 0? 2.
2.
Okay, so that's why they will be 2 U second, they go 1, and then they repeat again. Okay, and this one the same thing, they will be for you. After done, then say and not say it. Okay, your computer must get the directory scettio.a. That means inside your computer, in the C drive, you must get the directory ett, and you must be copying io.h header into that in order to run. Okay, so next time you will be get the drill lab, and we can helping you in order to do at the beginning to the end to get the answer for the B-Spy. Okay, now what I want you to do, you take the quiz now. I said what you need to do is try to repeat the handout over and over. If you want it, you can go into the web. When I upload the record today, try to understand. That will be help a lot. Okay, and now we'll be running. Try to see how many people can get through that quiz. Quiz number 2.
If any is not-
They say if A equal 1, what output X equal? Circle either high or low. 50-50.
1.
I don't know. Quick done it. Okay, let's see. I want to quickly okay. I'm going to make a noise to make sure you know stack up the question.
Mr. Pham, where is the quiz? Is it in handout or just right now we have to do it from the screen?
Now you are supposed to be already downloaded.
But where it is, I don't see the quiz.
You don't see the quiz number 2.
I say
Go
you
to
have,
the website handout for TechTube.
I say you have a 1 at X.
You don't see 2?
Oh, I see it. I have it.
Okay. That's
I'm just
for the
saying
last.
the
Wait,
answer
Right.
to the 1 is 1.
X is 1.
Yeah, go ahead and do it. Just a few minutes, not much. Yeah, if you really understand, I can tell you how they design the uh, line on the intersection.
Không. Một. Không. Bốn.
Okay, so I will go through the answer for you. Okay, try to explain to you. The answer for number 1 will be high. If you get a question, let me know, okay? And in order to draw the output height for the timing here, okay? So this is just the AND gate. So AND gate, if you get a 0, then you get a 0. Only thing you get the 1 when A and B 1. So that's why. First one 0, 0, you get 0. 1, 1, you get a 1. You can draw 1, 1 here, you get a 1. And the rest will be 0. Easy to get through it. Okay, this is the NAND. So, what the output NAND equal? I equal, not A and B will be not A. Or not B. Now, if one input 0, output equal 1. Okay? If you're looking into A and B, you get a 0 here, you get a 1. Okay? 0 here, you get a 1. 0 here, you get a 1. 0 here, you get a 1. Okay? And 0 here, you get a 1. 0, 0, you get a 1, and the rest will be 0. Easy to draw if you have to understand the equation, not A or not B. One input equals 0, then you get a 1. That will be the same thing. Let I copy that one. This is the NAND, and they get 3 input A, B, C. So they will be equal or not C.
It's not a dot instead of the plus sign.
That means not. Right here, right?
Right, it's an AND gate.
The thing I cannot draw over, bar over. So you can say not A, not B, not C. So only thing is when you see the input, 1 is 0, output must be 1.
The plus sign is an OR gate, right?
That's a NAND gate. not the or, not a nor.
Right, but the plus sign is A naught plus B naught. Is that a OR gate, the plus?
I'm not quite follow.
Plus sign is a OR gate. The plus stand for OR.
Is it this equation right or wrong?
It's correct.
That's right.
What I'm saying is, in order to get a quickly draw, you must be understand this equation. On this equation, only one input 0, output will be 1. So you're looking in here, you see any input 0, you get a 0 here, so take 1. Okay? And you can see right here, you get a 0. They will be a 1. And they is 0, they will be a 1. Okay, and here, 0, then you get a 1. And this will be 0, you get a 1. Okay, that means 1 input 0, output must be 1, and the rest will be 0. That's how you can get it done. And now they say following here, we get for this timing. So the answer will be the NAND. NAND means you input 1, output will be 0. If I'm looking here, I see the output 0 right here. I looking up. I say A1, B1, so that's why I get 0. So that will be telling you that gets up to be a NAND. Okay? And the next one will be the same thing. Okay? When you're looking a 0 here, all input have to be a 1, you get a 0. All input have to be a 1, you get a 0. The rest will be 1. 1 input 0, you get a 1. That means for the NAND gate. Okay? So this is the answer here. You want to converting from binary, hex to binary. X1 will be equivalent to 4 bit. Number 6 will be 0110. B will be 1011. And so on. Okay? What I expect you guys, every time we get a quiz, you can do without thinking. You get the answer. Okay? Otherwise, you still have to open the note or the book. That means it's not really good at all. Okay, any more questions?
Yes. Can you explain number 9, how you got that?
Number 9, convert the gray code to the binary. Okay, let's see. It's hard to do in here. I try to get that one for you. Okay.
Okay, thanks.
And our number 1. I'm looking for gray code here. Okay. Then
Question, Mr. Pham.
Yeah.
I came in a little late today. Did you go over gray code today?
gray code, I think we already done, right?
Yeah, we did it we did it last week. We touched on it.
Okay, I quickly. Okay, now they want you converting binary to gray code. So you get a number 10110. That binary. You want to convert into the gray code. First thing you take that one up here. Okay? And 1 you adding to next one adding to 0. You get a 1. no carry, okay? No carry. Then 0 here, you adding to next one, you get a 1 here. Then 1 here, adding to next one, you get a 0, no carry. 1 adding to 0, you get a 1. Okay? So this is how to converting binary to a gray code. And now we're converting from a gray code to binary. I get a 1, 1, 0, 1, 1 in the gray code. I want to convert into binary. Now, first thing, this one, you put it down here, 1. Then you take 1 here, adding to this one. You get a 0, no carry, okay? And 0 adding to this 0, you get a 0. And 0 you adding to this 1, you get a 1. And 1 adding to 1, you get a 0.
And this last one doesn't have a carry.
No,
You just write
no
the 0
carry.
down.
If you're reading to the handout, they're telling you no carry. Okay? So that's what I try to recommend to you. Read over and over the handout. I combine everything, even with the city college. So if you go into the city college, this is no big deal, no problem. The thing I
No,
get,
I just had I had made a mistake on the last one when I was adding the numbers.
okay,
Thank you.
yeah, no problem. Hopefully, next time we given you the quiz, then you can get it done quickly. That's what we want. They have to go into your brain, okay? Like myself, okay? I can see I can do it right away. That is the way you're able to get a technician job. Okay, the thing is you understand, I get a student, okay? They go into the city college. So that's why I collect all of the thing they done up there and I compare to my program and I try to combine to make sure, when you go up there, you still have no problem. And also, only thing we emphasize in this program will be doing the lab and solving the problem, okay? Anything you not quite understand, just let me know. We'll help you guys out. Any more questions? Anything? Okay. So I stop share it now.